Hello, my name is Owen Fennessy. Welcome to my video presentation on the game Bounce, a platform game where you play as a bouncy ball that has somewhat realistic physics. We're going to look first at some gameplay and then at some of the code that went into the game. Let's get started.
So when the game starts, we're met with the main menu. For now, we'll select a new game. We'll be prompted to enter our initials and we'll start on the first level. So you can see we can move left and right and we can jump. We can collect these coins. If we collect 20 of them, we'll get a new life, and you'll see those stats updating in the top left corner. The spikes here will kill us, causing us to respawn at the start of the level. This purple power-up reverses the force of gravity, causing us to fall upwards. And here it is reversed again. These orange tiles are springboards. They cause us to bounce higher and higher up to a certain point. That red power up is a extra life. These black balls are enemy balls. If we hit these, we'll also die. And some of them have horizontal movement as well as vertical movement. We're coming to the end of the level now, and this blue power up causes us to go to the next level. So focusing on physics now, there are various forces in the game, including gravity and the ball's jump force and move force. These are all added together every frame to make up the acceleration of the ball. This acceleration is then added to the existing velocity of the ball, which in turn is added to its position. Each terrain tile also has some opposing forces that act upon the ball. A friction force, which causes the ball to slow down when it is rolling, and a spring force which inverts and scales the magnitude of the ball's velocity. Each terrain tile can have different values for these properties, and the purple gravity power-up simply multiplies gravity and the ball's jump force by -1. Each level in the game is created by parsing a 2D character array, where each character represents a different object in the level. Lowercase characters populate a tile array, which makes up the terrain of the level, while uppercase letters populate a power-up array, and spaces represent the absence of any object. This makes creating levels with code much quicker and easier because it offers an immediate visualization of the level in code, and means the person designing the level does not need to concern themselves with the coordinates of every object. Instead, they only need to know what each character represents. This level you are currently looking at, which is the final level, was actually designed by my 12-year-old nephew with little help required from myself, only to add things like enemy balls and the initial ball position. When we get to the end of the game, our score is calculated by multiplying the number of lives by 20 and adding the number of coins. If the score is high enough to make the leaderboard, it is added to it along with our players' initials, and the leaderboard is then sorted. The game also features a multiplayer mode, where we can specify the number of players who want to play. These players will then take it on turns to complete each level, and the current player's initials are displayed on the top right corner of the screen. Additionally, a pause menu can be displayed at any time by pressing P. This will keep the state of the game exactly the same until the player presses continue. Let's now take a look at some of the code in the game. I thought the easiest way to give an overview of the game's construction was to do a simple class diagram showing the most important fields for each class. We can see that the very top box, which represents the main program class, consists of an array of players, a leaderboard, an array of menus, and an array of levels. Looking below it to the right, we can see the level class, which is composed of many other classes, including 2D arrays of tiles and power-ups, a ball, enemy balls, a camera, and an array of force vectors, as well as a key controller, which is a class that offers a flexible way of keeping track of the state of different key presses in various objects. Each class is fully encapsulated, and none of them reference anything outside of their own class. All class fields are private, and the access and modification of all fields is handled with getters and setters. Any change of state in nested classes, such as the power-ups class for example, that needs to affect sibling classes of the parent class, in our case the player class, first needs to be accessed by the parent level, and then accessed and handled by the grandparent class, the main class in this example. That's enough detail on the class diagram for now. Let's now look at some code. So here we declare some global variables, the tile size in pixels, an array of levels, an array of players, the current player, an array of menus, the leaderboard, and the font used for lettering. We then move on to our setup function, where we set the screen size, turn off our cursor, load a font, set the font, set up our initial player, get our levels, set up a leaderboard with 5 positions, and build our menus. The getLevels function is worth mentioning here, as it contains all the information needed to build a level. We can see there's character representations for everything that makes up a level, from the tiles to the power-ups. These are then put into a large two-dimensional character array, or actually it's an array of strings, but and you can see that it's quite easy to visualize what's happening in the level just by looking at this. And it makes the process of building the levels very straightforward. We then call 2 functions, getTerrain and getPowerups, which parse this array of strings and give us our arrays of tiles and power-ups for the level. We then set up a ball, some enemy balls, and we pass this all then to the constructor for our level and set it at the correct index of our levels array. Looking at our main draw loop now, we can see that we first check if the current level is being played. We then check if the current player has enough lives, and if both of these are true, we display the current level and update it. Then we go through our active power-ups and apply their effects. We then display the number of lives, coins, and the player name. Remove life from a current player if a death has occurred in the current level, and activate the pause menu if pause has been pressed. We also handle the case where the user has lost all their lives and return to the main menu. If the current level is not active, we then check to see if the leaderboard is active and display it if it is. We then display any active menus and handle any selections that have happened in those menus. Looking now at the display method of the level class, we can see that there's a translate method call which uses the X offset and Y offset from our camera class to move the camera. There's then some optimization to only draw tiles and power-ups that are currently viewable on the screen. And then at the end of this method, we remove this translate so that we can draw things like the player statistics, which are absolute positioned items. Looking now at the update method in the level class, this has been set up in such a way that no matter how big the level, how many tiles and how many power-ups it contains, only tiles directly around the ball where collisions possibly could happen will be checked. Then functions to handle these collisions are called. GetCircleRectangle intersection returns a 2D vector containing the length of intersection between the circle and rectangle on each axis. This section of the method deals with corner collisions, and this method uses these intersections to handle the collisions. That's all we have time for now. Thanks for watching.